Okay. Somebody sent me an email about a couple questions, 3 of them to be exact, that you couldn't do it, and so I'm trying to help. And the 3 questions, 13, 15, and 17. So if you don't know how to do it, you should just look this up. And I'm still not feeling too well, so hopefully I can help you. This question is said, find BD. As you can see, BD is, of course it's the unknown, but BD is also shared with 2 triangles, right? So this BD is shared with this triangle over here, and it's also shared with the other one, like this one. So when you went into a question like this, talking about finding BD, obviously what they are aiming for is they want you to see the side that's overlap. So DB or BD is overlapping with 2 triangles. So what you may want to do in the beginning is to draw this 2 triangle out. So this black one is that yellow one. So it's A, B, and D. So the 90 degrees over here. And then I'm going to draw the green one. Let's just stay with the green one then. Okay, let's do the green. The green one looks kind of like this. X, B, D, C. So you have all those vertex over there, and you may want to fill in those numbers as well. So you have a 2 over here. So obviously once you have these 2 triangles broke up like this, what you may want to do is obviously you want to rotate this triangle so that it's going to be in the same orientation. That's what I would do. Let's see if I can do that. Let's see if I can rotate this or not. Okay, so the B, the D, the C, this X is a little bit odd, so we are going to erase that and just weigh it again. X. So now you have the setting. So you are comparing the sides, the corresponding sides. So AD is going to compare with BD, and then this BD is going to compare with that. So I may want to weigh that out if I have to weigh out all of the steps. AD over BD, because they are of the same color, and then it should be equal to this DB equal to that DC, right? So you're comparing those, and then finally you're going to just put those numbers in there. So AD is going to be 2, BD, that's something we have to find. This DB, BD, same thing. DC is X. So once you set this up, cross multiply, right? You're going to cross multiply this. BD square, BD times BD is BD square. 2 times X is 16. So finally you do a square root on both sides. BD is equal to 4, right? 4. So that's A. Okay, so this question is all about, can you break the 2 triangles apart? Alright. Sorry. And once you break that 2 triangles, you try to set them up with the same orientation, like same orientation. So the 90 degrees are both pointing up, like in this scenario. So you can pair those sides. And once you set that up, AD over BD is equal to this BD over CD. Same color. Cross multiply, square root. That's basically it. You'll get 4. Hopefully that helps. Next one. This one is what we call the side-splitter theorem. Side-splitter theorem basically said if you have a triangle and you have a line in the middle that is parallel to the base, so that's actually what it means by the side split. So you have these parallel signs. So this actually ties to the parallel line, P-A-L-A-L-L. So in order to use it, you gotta have the parallel lines, which I do. They are parallel. So if you have that scenario, the proportion is compared like this. The sides are going together. The sides are going together. So what I mean by that is 5 over 2x minus 8. So this proportion is just formed by one side of your triangle. Okay, wherever they cut it, just follow the direction. 5 over 2x minus 8 is equal to 3, right? 5 and 3, they are at the same location, so 3 over x minus 3. So if you use the side split, it's a little bit different than all other triangles we've done before. We are actually comparing things on the same side. So after this is just cross multiply. So 5x minus 15, 3 times 2x is 6x, 24. Okay, so moving things around, what I would do is I would move the 5x to the other side, because I'll get a x over here, and then I'm gonna add that 24 to the other side, adding the 24. So I add a 24, add a 24, 24 minus 15 is 9, so x is 9. Okay, so it's side split theorem, and it's the last couple theorems, and then the other question obviously is the last question, last theorem. Side split theorem, you need to have the parallel lines. Once you have it, it's comparing just one side. Alright, it's really not too difficult. Okay, angle bisector theorem. Angle bisector theorem is you have a triangle, you have a line in the middle, let's say like this one, right in the middle, FD. It bisects the angle. So the bisector basically means it cuts the angle and they're equal. So in this scenario, the comparison is kind of similar to the side splitter. What they said is, if you have an angle bisector, you have two triangles over here. Just pay attention to the color and what are the things that go together. This and that go together. The base go together. The side go together. Okay, it's all about color coordination, matching up the color, that's all. So in this scenario, x over x plus 10, 24 over 54. Alright, this whole chapter, this whole thing is about setting up the proportion and then do the cross multiply. And hopefully they don't have like quadratic equation in there. You can ask Period 4, they did that today. I don't know. So 54x, 24x plus 240. I will subtract this. 54 minus 24 is going to be 30, isn't it? 30x is equal to 240. Divide both sides by 30. Should be 8. Alright, so these three questions, they are of different format. The first one was the original comparing corresponding side. This is about corresponding side. I can't spell. So this one is about corresponding sides. And then side splitter, you have to have parallel lines in the middle. And then you're comparing these two. Alright, finally, angle bisector is comparing the base and the side. So it's all about patterning and see if you can remember the different types of patterns. Alright, and I hope this helps. I'm not sure if I'm going to be okay to be back tomorrow, but because you asked this question and I won't be able to answer it before class anyway, so I'm creating this video for you. Alright then, bye for now.